press the button on YouTube right now. Is that true? Yes, and I believe we are in. Okay, beautiful. So then let's get started. Welcome, everyone. Very happy to be here. My name is Jose Luis, and I teach this class called Introduction to Computational Design at the Harvard Graduate School of Design. And I'm very happy to invite you all to the first in our guest lecture series. I'm happy to invite you to the lecture with our first guest, Matias del Campo. Matias, you want to say hi?
Hello, everybody.
Hi, everyone. So before I introduce Matias, I would like to remind all of us of a few of the logistics of how this lecture is going to be conducted. This lecture is open to everyone. We're conducting it with a Zoom call. So people who are on the Zoom call are people from either the Introduction to Computational Design class or the GSD community. This lecture is also being streamed live right now to YouTube, so where it's open and free for everyone in the world. So if you're welcome to keep your cameras on and off as you please, if you're on the Zoom call, but if you keep it on, just a reminder that your image may actually be showing on our YouTube live stream right now. So the way we're going to conduct this lecture is that I will introduce Matias, then Matias will share some of his thoughts with us on architecture, artificial intelligence, and the intersection thereof. And then after that, I will open it up to questions, first to the people who are here on the Zoom call right now, and then I will relay questions from people on the YouTube live stream. So all of you who are on YouTube right now, I'm seeing you over there on my other monitor. All of you, you're welcome to post your questions on the chat, and I will be the one relaying them to Matias after in the Q&A session. And with that, I am going to formally introduce Matias. So Matias is a registered architect, he's a designer, and he's an educator. He's actually an associate professor at the Topman School of Architecture and Urban Planning at the University of Michigan, where he's also the director of the Architecture and Artificial Intelligence Laboratory, AR2IL, at the University of Michigan, and an affiliate faculty member of Michigan Robotics, Computer Science, and Data Science. That is a lot, Matias. Matias is also the co-founder of the architectural practice SPAN. The practice has gained a lot of wide recognition recently for the design of the Austrian Pavilion at the 2010 Shanghai World Expo, and more recently at the Robot Garden for Ford Robotics Building. SPAN's works was featured in the Venice Biennale and Buenos Aires in 2019, and his solo shows include Formations at the MAC Vienna and Sublime Bodies at the Fab Union in Shanghai. The work by SPAN is in the permanent collection of the FRAC, the MAC, Benetton Collection, Albertina, the Pinakothek München, and several private collections. His publishing works includes 2 editions of the AD Evoking Through Design and Machine Hallucinations, both co-edited with Neil Leach, or maybe just the second one? No?
Just the second one.
Just the second one, exactly. As well as the books Neural Architecture, Design and Artificial Intelligence, from oral editions from this year, which I believe he may actually be talking about today, and Sublime Bodies, which was co-authored with Sandra Manninger from Tonji Press in 2017. With that, I would like to shut up and give the stage to Matias. Thank you very much for being with us today.
Thank you, Jose Luis, for the generous introduction. I'm gonna share my screen. I hope you should see my presentation now. Does it work?
Yes.
Okay, excellent. So first of all, thank you very much for the generous and really great introduction. I'm briefly going to repeat. I'm Associate Professor of Architecture at Topman College of Architecture and Urban Planning at the University of Michigan. And together with my partner, Sandra Manninger, I run the architecture practice SPAN and co-founder of the ARIL laboratory at Topman College. So I'm bringing to you today the lecture on neural architecture, design, and artificial intelligence. that is based in large parts on some thoughts, ideas, and concepts that I put together in the book Neural Architecture, which is currently have been available now for the last 2 weeks or so. Finally, it was supposed to come out in spring, but all this delivery and delivery chain problems delayed it a lot. So the basis of the lecture is the idea of how to basically introduce a conceptual idea on using AI in architecture. So this book is on the one side probably more sort of a theoretical book and less a practical book on AI. There's a follow-up book coming up late this year, which is going to be primarily the conceptual idea of the mathematics and algorithms behind what I present in the book. So it starts with the chapter, "This building does not exist," an attempt at a theory of neural architecture, and then continues with ideas such as computational vision as design method, or questions such as style in artificial intelligence and architecture. It contains also an entire chapter on aspects of language and architecture, which has become very current with the emergence of Midjourney, DALL-E 2, Stable Diffusion, etc. Chapter 6, for example, deals with the important question of how machines learn to plan, and continues with the questions of applying 3D mesh models in neural network algorithms. The book ends with a statement about the politics of neural networks and artificial intelligence. And Mario Carpo was so kind to provide the preface of the book, which consists of a fascinating story about the compositional technique used by ancient Greek sculptor Zeuxis in the creation of a Venus statue. And he compares it with the work we have done on generative adversarial networks. So what is neural architecture? Neural architecture is the field of architecture that is primarily preoccupied with interrogating the emergent field of artificial neural networks as a method of designing in our discipline. INNs can be described in short as a sequence of mathematical algorithms that are capable of registering latent correlations in a set of data. In this lecture, I present an attempt to utilize deep learning and machine learning to capture the salient features of existing architecture in order to interrogate this data for their underlying architectural qualities. So what is meant by underlying architectural qualities? The rational explanation would include aspects such as spatial layout, sectional distribution of volumes, the dialogue with its environment, the volumetric balance, the material qualities of the design, the structural properties, etc., etc. All of these are things that can be explored with the help of machine learning processes. However, the ambition of this lecture and the projects presented in them maintains that architecture is more than just an assemblage of rational properties. This might explain also the obsession with neural art that I have, which represents an excellent mirror of our contemporary age, particularly regarding our shared agency with quasi-intelligent machines and their observation of the world. Can architecture do the same? Can neural networks help interrogate the latent layers within the geological deposits of the history of the architecture discipline, and then assemble those found features into hitherto unseen designs? So what is the context of which this idea emerged? And the main question that comes immediately after that is, why use an AI at all? So the basic simple answer is it's better to teach machines how to learn instead of how to do things. And what do I mean by that? I will illustrate that with the history of welding robots. Until 50 years ago, primarily this was the way how cars were welded together. People mastered the way of how to weld them. They knew exactly which points are good to get this, to create a stable and good result. Move forward, and in the late 60s, and I think 1967 was the first time that actually robots were used in an assembly line to weld together cars. Now, if you think about this, the car industry has been collecting data points about welding points for over 50 years. This is a massive amount of data, which actually means we can actually take the data to teach a machine, not necessarily which exactly welding points to use, but rather to teach it what is a good welding point. The main difference between these two ideologies and ideas of fabrication is that in the previous history of using robotic tools to fabricate cars, somebody had to train a robot literally where to weld specific parts of the car. In the new idea is not anymore to teach a robot specific points, because that means basically that every single time that a new car is being designed and put into production, you have to change this whole production line and teach the robots again. But instead of doing that, which is very costly and time consuming, the robot adapts to the situation, meaning that every single car that comes along that assembly line can be a different model. And the robot learned where it is good to weld, so it knows automatically where to do that. That, of course, means that a lot of time, effort, energy, and money gets saved by that. Now to another area of interest within why to use AI, and also the idea of the rise of neural art. So the book takes the title Neural Architecture, and it borrows that basically from the art and the music field, where things like neural art and neural music already exist. You might have seen this painting already before. This is the portrait of Edmond de Bellamy, which was created by the Paris-based art collective Obvious in 2018. It became notoriously famous after selling at Christie's for a whopping $432,500. It is allegedly the first entirely AI-based piece of art. The name Edmond de Bellamy is a tribute to the inventor of the gun, Ian Goodfellow. No? Bellamy, Goodfellow. And more importantly than the price fetched or the particular AI technology used are fundamental questions regarding the agency, authorship, and sensibility, which appeared in the wake of the media frenzy around this painting. Who's the author of this piece? Is it the art collective that came up with the idea to use the neural network? Is it the programmer who set up the algorithm? Is it the hundreds or even thousands of artists present in the dataset used to make this painting? So who has the copyright of something that was not created by humans? The rise of neural art became very visible around and after 2018 with artists such as Sofia Crespo, Mario Klingemann, Memo Akten, and others who embraced the use of AI as a legitimate form of artistic expression. And it cannot be reduced to the visual arts alone. Musicians, neural musicians, such as Holly Herndon, Arca, Yacht, and Dadabots use AI to make their artworks. So one of the earliest adopters of neural networks to create works of art is actually literature. And there are so many examples that I could do an entire lecture only on that. So even before I became aware of this art tendency, we started already experimenting with things like undertraining, overfitting, data scarcity, with a variety of different neural networks, and with the help of the computer science department of the University of Michigan, who were really very helpful in setting up a variety of neural networks for us to experiment around with. And after these first modest efforts, some crucial questions emerged about the being, becoming, and reality of this architecture design methodology. We had the same questions about the same questions that also emerged in the arts about agency, authorship, and sensibility in a post-human design ecology. So what is the architect's role in a context where the sole authorship is not in the human anymore, but when agency is shared? These questions help in the critical interrogation of designs embedded in a world increasingly entangled with the various aspects of AI. They provided the bedrock for the ontology of neural architecture. In the following, I will focus on some theoretical aspects that I discuss also in the book and in actually pretty much every paper I've written since I started doing the book. So estrangement and defamiliarization is one of the main particular aspects that I think is really interesting within this whole new ecology of design. Defamiliarization, or ostranenie, is an alluring area of consideration regarding the discussion of architecture design with the aid of neural networks. The term itself was coined in 1917 by the Russian formalist Viktor Shklovsky in his famous article Art as Technique, and describes an artistic method that provokes the audience with imagery depicting everyday things in unfamiliar or strange ways. The goal was to provide the audience with the opportunity to gain new perspectives and observe the world through a different lens, through techniques that introduce abstraction into the aesthetics of realism. The concept was influenced by 20th century, the concept actually influenced 20th century art and theory, including Dada, postmodernism, epic theater, science fiction, and philosophy. Additionally, it is used as a tactic by recent movements such as culture jamming. Estrangement and defamiliarization are actively present in the works of Hegel, Karl Marx, Victor Schlowski, of course, as mentioned before, and also famously in Bertolt Brecht's theater works. And of course, a thorough interrogation of aspects of estrangement and defamiliarization cannot be complete without at least mentioning Sigmund Freud's essay, Das Unheimliche, the Uncanny. Freud defines the uncanny as deeply rooted in what is known to individuals as common or familiar. Deviations from the familiar defamiliarization or defamiliarizing aspects of life, for example, result in emotional responses akin to fear or curiosity. So it is remarkable to me that diffusion models are capable to interrogate the latent space of an enormous image data set towards the aspects of estrangement, autonomy, and defamiliarized categories of design. And this is, I think, for me, the most interesting part of working with AI in architecture at the moment, apart, of course, from all the possibilities that you have to optimize things, right? I mean, I'm definitely rather interested in the cultural interrogation of this tool more than its totally practical application. This is something that for me is a layer that is also there, but can also be discussed. But my focus is rather on the cultural aspects. One thing that I notice is that it is probably the first genuinely 21st century design method, because if you think about it in terms of computational design methods, the vast majority of those were already present in the late 90s and have been perfected and streamlined in the last 20 years. Like things like parametric modeling, agent-based modeling, scripting, versioning, blobs, folds, etc. were all already out there in the late 20th century. Neural architecture is a new paradigm, not only intellectually and culturally, but also technically. What we see today was not yet possible even a decade ago. Let me show you some examples of what we do in our practice with this. Jose Luis mentioned already at the beginning the robot garden, which we designed for the new Ford Robotics building at the University of Michigan. This was a commission done by the Department of Robotics, which basically we're looking to create a new testing ground for their robots with legs. So one of the specialities at Michigan is working with robots with legs and trying to understand how they perceive the environment, how they basically can serve the environment. There's the famous last 100 step problem, which means that robots can perceive really well and work really well in conditions that they're known, that they know. But as soon as their conditions change unexpectedly, they have trouble understanding the environment and react accordingly. The last 100 step problem basically has the idea, if you want to have robots that basically do, for example, Amazon deliveries, they will encounter a variety of different conditions when they come to different houses. So that's what they're working on, and that's what they needed. Basically, a testing ground that had a variety of different ground conditions, but also steps and things like that. And what we did was basically we combined several techniques that included deep dreaming, 2D to 3D style transfer, style transferring in general, to create a variety of 3D models that allowed us to explore the possibility to create this testing ground with a variety of different conditions on them. And this is a recent video that I got from robotics, and which I like a lot because basically it shows how robots perceive that garden. I'm very much fascinated by the way how robots or machines really see the world. It's such a different and alien and strange way, although very logical and totally practical. But at the same time, it also generates its own aesthetic. This is part of the data set that we use to create the data set for the ground conditions on the site. We were looking for a variety of different possibilities to dream or hallucinate, but also just style transfer those on the site. And not all results were usable. Like this is one, for example, that is definitely actually one of my favorite results. It's so strange. I love these beautiful errors and glitches. And it has probably much more to do with how machines perceive architecture than how humans perceive architecture. Let me talk a little bit about text-to-image generation. It has really arrived in the mainstream. When even John Oliver talks about Midjourney, then it means that it is profoundly part of the mainstream. And I think this is an interesting development specifically for architecture. This is the first time that a tool is widely available for everyone to use and play around with possibilities of using ways of how machines perceive the world. If there is at the moment like 10,000 of architects playing around with Midjourney, and only a couple of them remain interested in AI and architecture, we will have a really interesting conversation in the upcoming years. For me personally, I think that Wittgenstein's quotes, "The limits of my language mean the limits of my world," capture really well what those text-to-image algorithms can do for us. One of our first attempts to try that was in 2020. We were not using a diffusion model back at the time. We were actually using an attentional gun to create a high school project for Shenzhen in China. You see that the images were very small scale. They were very raw. We used like really very simple methods to translate those images into a 3D model by just using a depth mapper in Grasshopper and trying to extract or extrude the volumes out of the given image. It was quite a large scale school with it's a school for 3,000 students that included dormitories, gyms, large fabrication facilities, libraries, in administrative buildings, etc. So it was really large, but we also found out the hard way what the problem is with creating from the visual imagery that you get from any sort of text-to-image algorithm a three-dimensional volume. There's no way to understand the interior. So there's a huge divorce between interior and exterior going on when you're using neural networks to design architecture. Instead of being worried about that, I actually embraced it. And I thought, okay, well, if this is how this works, then we're going to just work that way. We're going to create one algorithm that deals with the interior and another algorithm that deals with the exterior, and then combine the models with each other. In the future, we're going to try to combine or concatenate a variety of algorithms together that deal with the interior and the exterior at the same time. But I don't think we're there yet. But what is actually really fascinating about the emergence of image-to-text diffusion models like disco diffusion, I think this was the first one I heard one was actually disco diffusion early 22, is the ability to create variation. This is a profoundly architectural way of thinking about a project, the idea of working through iterations continuously to come to the best result possible. So if people, for example, sat down and made hundreds of drawings and sketches to come to a solution, this was also a form of versioning. I remember really very well doing dozens and dozens of foam models when I was working for Hans Holm back in the day, creating variations of a specific project or problem in order to find a solution for the design. What is happening with the use of diffusion models is the augmentation of that process. So I made a little math recently and came to the conclusion that from April, when I started using Midjourney to recently, I've created more than 75,000 images. And I'm not the most, and I'm not a power user in that. There are other architects who have done even more than that. So the tool basically amplifies and pushes your abilities to create variations as an architect to a new limit, or expands that profoundly, which I think is an interesting problem. I'm just going to explain how diffusion models in the very basics operate and where they come from. It actually started 2015 with the idea of automated image captioning. What happened back then is that the data sets were big enough of different data sets that are out there for image segmentation and object detection, that actually it was possible to create an algorithm that could define what's happening in a scene. So, for example, if you showed this one to the automated image captioning based on a natural language description, it would create something it could create a caption that says something like people walking on a bridge. The main idea that happened after that was, what if we turn it around? What if we create the sentence first and let an algorithm create the image out of it? So create a caption called "people walking on a bridge" or a prompt, and then that would create an image. This was an idea that came from Enmal Manisov and others at Amazon Web Services, who also published a paper around the time called "Generating Images from Captions with Attention," which was published in 2016. Now, what diffusions in their basics do is that they actually you can take an image and then add noise to it until it becomes just a noise image. And then you can reverse that to generate a new image out of it. Yeah? This is a process that goes back and forth many, many times within the process. So basically what it does is it takes a random pixel image and then can organize the pixels based on the prompt. This is like a very simplified way of explaining it. This would be also a longer lecture, I guess. I was curious to see, like, one of the things that is I think a problem in this is how easily it is to fake architecture. Like, if you just use a simple prompt like Mies van der Rohe building, you will get some results out of it that are quite convincing in terms of what they do in representing a possible project by Mies van der Rohe. But it also very much, I almost think that they are very close to being overfitted to reproduce images that are present in the data set. On the other hand, you can prompt things like section drawing through an opera house, and you will get something that resembles a possible section of an opera. Of course, it's completely unfunctional if you look closer into it. It's not really the section of an opera, it's the hallucination of a section of an opera. But that hallucination, I think, can help to spark the creative process in an architecture project. So I see those tools more as an expansion of the possibilities of an architect, not as a restriction of the possibilities of an architect, as long as it is used in that way, in an imaginative way. Unfortunately, there is many people out there who use these tools very unimaginative, trying to emulate particular styles or particular architects. And I ask myself, why do you use it that way? I mean, those people exist or existed, they had their work. Why don't you use it a little bit more imaginative, and instead of prompting particular architects or styles, try to describe their architectural quality or the architectural space that you want to create, and combine it also with the features of anything around you, might it be nature or art history or weather phenomena. Yeah? And they will create things that are really interesting. I actually had quite some fun doing things like this, asking an AI, what's the most beautiful house in the world? And that's what you get in return. Not for me, but maybe some people would like to have that. I created like a variety of, talking about this idea of describing maybe things in a different way. These were sort of like the first things I tried in Midjourney. And I tried doing things like a hairy villa or a scaly house or a house made of feathers. And admittedly, I also tried to do things like Le Corbusier house made of Kobe beef. But if you move away from that and really try to evoke other qualities in the architecture, I think when things start to become interesting, when suddenly through many iterations and variations, you get to things that are really very, I would say, have their architectural qualities and can also describe more surreal elements like an orchid tower. I liked it when these projects start to have that very defamiliarized quality. And you remember that I talked about ostranenie and estrangement and so on. And this is really where my interest lies in this new development, is trying to understand how these novel tools create an imprint in our contemporary culture by mining our whole history of a discipline and then putting that in perspective of a possibility to create something that might be new. New is a very strange and difficult category to talk about. There's a lot of really interesting research going on about AI, creativity, problems of the new, like how do we as humans understand concepts like new, and why we very often don't even see when something new is in front of us, because we do not have a referential system to understand that it is new. So we need time to get used to it, it seems. Another project where I worked not with a diffusion model, but with StyleGAN 2, was a project that interrogated exactly this idea of the very deep repository that exists in our discipline. I basically mined every single possible section, plan, elevation, and picture that I got from brutalist architecture, and then created this and as a very intentionally. So I don't know if you know the problem of curve fitting, but I'm gonna just say curve fitting exists, and when curve fitting is too good and too close, it just becomes realistic and is boring. But if you are sloppy with the curve fitting, you can come up with things that are really interesting, strange, wonderful, alien, beautiful. And this is exactly what we did here. We trained actually a neural network to loosely understand what brutalism architecture is. We created a latent walk of it. And then out of this latent walk, we selected a series of images that we used then in a pixel projection process to create a model. And the model should actually come up every second now, I hope, in this animation, which is rather short. So this was the pixel projection of 2 or 3 selected images. And those basically provided us the result for a project that we were working on, which is the Generali Center at the Marie-Hilfer-Straße in Vienna. It's a combination of a shopping mall, office space, and apartments. But this project also shows how much sort of post-processing is still necessary to get to a project that is architecturally viable. So we got like a really interesting base for the project, but everything else like circulation, staircases, platforms to stand on, floor plates, walls, elevators, like all of that had to be added basically manually. Right. So it shows also, again, this process that working with AI does not mean that everything is going to be resolved for you. And AIs don't do anything on their own, by the way. They always need a base to work on. But once they provide you with an inspirational model, you can continue creating something around that. And I think that's like the biggest takeaway for me from working with AI at the moment is that, yes, you can optimize a ton of stuff. Yes, you can use it also as a creative tool, but there is still a lot of human labor still involved in creating a viable architectural project out of it. And another one where we did something similar was the Deep House, which we created for, funny enough, that's actually for a neuroscientist from Austria, a neurologist. He saw the work that we're doing, and he read that we have like this, we understand that there's a neurological background to what we're doing here. Like every AI process basically is based on the current understanding we have about processes in our mind, and then replicates that in an algorithm. And he was really interested in that and thought like, can we do like a house that reflects his discipline? But the one thing he wanted to have something that resembles a mid-century modern house. So we created, again, another data set with tons and tons and tons of elevations from mid-century houses. And again, we intentionally had like a really sloppy curve fitting going on here in order to create a result that has more of those strange elements to them that I like so much. So this was the final result of it. So it has, of course, a lot of these very clear modern features, but on the other hand, it also has a lot of things that modern architects would never have done because it would have been a waste of material or not clear enough and so on. And I like those moments, like these strange wall separations here, and the way how interior and exterior is separated by these volumes that are penetrating the space. So to come to sort of a closure, I would like to say that I also founded the Neural Architecture Group together with Daniel Boloche and Emmanuel Koh and Sandra Manninger, which is a group that really tries to meet on a regular basis and discusses a variety of different aspects of this emergent new field of architecture design. You can also check out the aiarchitects.org website, where I'm continuously collecting positions regarding the use of AI in architecture. Recently, one of your colleagues, Andrew Witt, also joined this website. Very happy about that. And as mentioned at the beginning, I founded also the ARIL laboratory, which is focusing on architecture and artificial intelligence, particularly working also on pragmatic applications of this tool by, for example, doing projects like the Common House or the Model Mine. Architecture still does not have enough really qualitative good data sets to work. And we're trying to solve that by crowdsourcing 3D models and annotated plans. And there's also a YouTube channel, Remeshing-AI. And with that, I would like to say thank you very much for giving me the opportunity to speak to you. And thank you, Jose Luis, for this great opportunity to present the book. But also, if you're interested, there's an AD that recently came out, Machine Hallucinations. And later in fall, there's going to be a Springer book called Architecture in the Age of Intelligent Machines that basically summarizes the more dry, technical, algorithmic, mathematical background of this new development. So thank you very much. Highly appreciate it. And I'm curious and looking forward for your questions.
All right. Thank you. I'm going to do a physical applause. All right. Thank you very much, Matias. I would like to invite all of us to offer questions or comments to Matias. The way we're going to do this is I'm going to start with us here in the Zoom call. So if you want to offer a question, feel free to post it in the chat or to just raise your hand virtually here. And for those of you on YouTube as well, I see some questions already, which I will relay to Matias once we're done here with the Zoom call. But if I may, in order to break the ice, first of all, I want to thank you, Matias, for being here. I know you manifested interest in coming in person, and I kind of invited you to do this online in the spirit of like making this as open and as available to the wider community as possible. So that one is on me. And I was very happy to hear from your conversation. What I perceived was your angle as of, hey, listen, like we have all these new tools. They're helping us spark our creativity. They're helping us support our creative processes, but it's nothing perhaps like so different from the techniques that we had before, even though you made a very clear statement, like this is perhaps the first genuine 21st century design method, just because any other computational methods somehow were inherited from earlier computational technologies. But I want perhaps to relate this idea of AIs as partners in creative processes related to like old school thinking, like for example, Norbert Wiener with his cybernetics, and like in the manifesto being super clear already in 1948, like, hey, listen, we lost the race with machines about labor, so there's no human these days really that can compete on selling his labor against machines. And very soon, I think he was saying something in terms of no human who doesn't have like mental capacities that are worth competing with a computer will soon also become undervalued. So I wonder, where do you stand in this conversation? Where do you think the prevalence of AI is leading us? What do you think the role of humans is going to be in a world where AI is so pervasive, is so good at perhaps generating synthetic architecture from scratch? Where do you think do you stand in that conversation? And perhaps if you want to even venture to this, how do you see architectural design in like 25 years? If this is a tool, and if all of this will be very soon ingrained in Rhino, Grasshopper, or whatever the likes of tools we're using for designing architecture in 25 years. Well, how do you see this?
Yeah, that's a good question. I mean, let me put it this way. I noticed that when I really talk about the rather radical possibilities of this technology, people get afraid, and I don't want to scare people. So, by the way, I think there's there's a lot of nuances in how you can apply these tools. It's not just all or nothing, right? So I think that there is on the one side the possibility to really automate a variety of design processes, right? Up to the point probably that AI is going to be pretty good in designing conventional, simple architectures on its own in a couple of years. I don't think this is going to be like a difficult thing, and I'm so sure that the construction industry is going to jump on this, and investors and developers, they're going to be so happy about this, and it's already happening. It's already starting to be implemented into those fields. But I also do a really big, for me, there's a big difference between architecture and building, right? I mean, yeah, because not every building is architecture, in my opinion. Yeah. And I think that's the field where AI is going to shine, in that part where that sort of human cultural desire or ambition is not necessary. Yeah, that's where AI is going to shine in terms of automating stuff, right? I still think that there's so many aspects of human creativity that cannot be encapsulated in mathematics yet. I'm not saying it's never going to be possible, but at least for the moment, like things like intuition, talent, sensibility, like those things are really hard to encapsulate because we don't know, neurologically speaking, enough to be able to do that. So we can encapsulate things like how dreams work, how hallucination works. Like we know how this works more or less, right? So we can put them in an algorithm and use them for, any sort of AI application. Machine vision is based on what we understand of our human visual cortex. Yeah. Mm-hmm. So to your question, where I see this going in 25 years or so, I think like there's a couple of scenarios which are really interesting. Like on the one side, what I'm pretty sure is going to happen is that there's going to be a renewed value for completely handmade stuff. So like if you have like an architecture practice that is going to insist to make things on paper with ink and pen, yeah, that's going to become like a really interesting luxury product for rich people who are going to afford that. Yeah, because it's so special and so different and so unique, right? And then on the other end of the spectrum is going to be like the fully automated, large-scale architecture office that's going to be run by 2-3 people, and the rest is going to be just machines that actually are able to manifest certain ideas of architecture that these people are going to talk about. Yeah. So
I'm traveling right now to 1920 and to the whole conversation about the arts and crafts right after the Industrial Revolution and the value of yeah.
And things repeat. I mean, humans forget very quickly. We know that. Yeah. and then the third part is that I think a lot of the architecture industry is going to change in directions that are maybe surprising to us. For example, creating data sets and talking and making sure that ethical ideas are followed. And, how do you deal with bias in architecture data sets? How do you deal with racial bias in data sets? Things like these are going to become a problem we haven't even scratched on in our discipline, but we need to discuss those. Yeah? That's why I mentioned at the end that there are no good data sets for architecture design at the moment. And what the smallest amount of architects understand today is that everything that AI does is based on data sets. And if you don't have good data sets, you don't get good results.
Mm-hmm. I hear you. Which also, I try to have this conversation with my students a lot and foreground the idea that bias in a data set is something that right now we're having so many conversations around, but we tend to forget that any design tool in a way has an inherent bias. Whoever designed the tool brought in their own biases to that design tool. There's no thing such as like the pristine abstract design tool. Photoshop has biases. AutoCAD has biases, right? But the fact that AI it's so prevalent is kind of interesting because of how it's based on data and data sets. I would like, so there's a question in the chat. Stephen, I wonder if you want to relate that question yourself, or I'm happy to do it on your behalf. By the way,
sure.
happy to see you here. Welcome.
Yes, sure. Happy to be here. Wonderful talk. Wonderful challenging. This whole emergence of neural art has made a lot of painters very nervous. And I'm so reminded of this, allegorical story of a million monkeys typing at the million typewriters will one day produce every great novel. Now, that pushes us up against the conception of infinities. An infinite number of possible things surely contain everything that's important, and therefore, if you could ever get to, and that's sort of mathematically boggling. The generative adversarial networks that are driving all of these things are such a reflection of what Herbert Simon called the simple generate and test paradigm, right? Make a proposal, see if it's any good. If it's any good, you're done. If it's not, change it somehow. So where do you see the inspiration part or the germ part other than from the data sets? Is there anything beside the data set that's actually part of the input?
Well, I mean, I think that the main difference is that generative adversarial networks actually are able to learn, right? And I think a monkey probably doesn't have, or I don't know, maybe monkeys learn too. I'm not entirely sure. I just don't know that. But what I know is that a generative adversarial network can learn features, right? So that's why it, for example, can create convincing looking human faces, because it learned the features of a human face. It understands there's eyes, there's a nose, there's a mouth and ears and so on. And it's able to from these learned features to put together a new image. So, I mean, maybe to go a little bit back of how a generative adversarial network actually works. There is one algorithm is a generator. It creates images that are based on the features it learned from a large data set of faces, for example. Let's say 3 million faces. Yeah. So it learned from those images what is noses, eyes, etc. And this generator can create new images that are similar, but not the same like the ones that are in the data set. Yeah. And this image goes then to another neural network that is the adversary. That's why it's called a generative adversarial network. There's an adversary that checks that image. And it checks the image and says, yes, it's convincing enough that it could fool a human, so to speak, or no, it's not convincing enough. And then it goes back into the network until it is retrained to become convincing. So these two networks that are basically fighting each other is what makes the high quality of the results in a generative adversarial network. And of course, the size of the data set, the bigger, the better. Yeah. So I think it's a little bit more sophisticated than just creating so many variations that at some point there's going to be a human face that looks convincing. Does it make sense? Does it answer your question? Yeah.
Yeah, and it's not a question that has a correct answer, by the way.
Yeah, you're right.
Thank you, Stephen. I see Van Crispin has also posted a question. I wonder if Van wants to relay the question themselves or if I can do it on their behalf.
Hello, yeah, my name is Rose. I was just wondering with just the emergence of AI and how it's continued to grow and expand, if how you would imagine from a cultural perspective that would influence vernacular styles that are really connected to specific cultures, and do you see data sets being produced for specific places, or that would like spark more ideas and possibilities, or do you think that vernacular culture could become more homogenized?
That is a great question, Rose. Thank you so much. I really appreciate that one. We have done in the lab some research in that area, and also, like for example, the apartment plan data set that we're doing was intentionally annotated by people from all over the world. We wanted to avoid, having a bias towards Western architecture in that. And while we were doing that, we discussed exactly what you were asking here. Like, like, what does it mean for like particular vernacular localized ideas of architecture or styles? Are we creating some sort of international style with that data set, right? Because it's homogenizing basically ideas about housing from all over the world. Is that a good idea? So there's the danger of homogenization here. Yeah. On the other side, we were talking about the possibility to give architects options how to use this data set, because all the plans are geolocated, meaning that an architect who's sitting in Egypt could say, give me a radius of, I don't know, 500 miles for my data set. Yeah. And you can even get it closer and closer and closer. The only problem when you get closer to your own location is that the data set's going to become smaller and smaller and smaller, and the results are going to, not be that good. So I hear you, I understand you, and I have to repeat what I said before. It's about the scale of the data set. And what I think is completely absurd, by the way, is that we are probably one of the small amount of disciplines in the world who can easily reach back to, let's say, 3,000 years of planning. Yeah. But despite that, we are very data poor discipline because we were not really good in organizing that information and that data and that know-how and so on. So in short, there is a danger of homogenization, and I agree with you. I think that people probably will have to create data sets that contain what they're interested into, yeah, and work with those. That's why I was saying that architects are going to go to create data sets in the future.
If I may extend on that idea, Matias, my friend Nono Martinez Alonso, who's also an alumnus of this class, by the way, when he talks about the relation of AI and architecture, like one of the things he mentions is that one of the interesting new things that AI as a tool is opening us for designers is the fact that all of a sudden, because AI is trained over large data sets, the curation of that data sets is a design project in itself. And it's something that is actually quite accessible to designers. So to your point, Rose, if you're concerned about particular architectural style, if you're concerned about the relation to vernacular cultures, something that you can use as a design tool is saying, well, what if I create a data set that is like 75% this particular style and 25% images of this other particular style? Let me explore what the AI is going to give me as like this kind of blend that I am curating of those images. And it's part of one of the beauties of the exploratory process that new tools are opening up, in my opinion, perhaps.
And actually tools like scraping are a possibility to do, like everyone can do scraping these days, like really search the internet for specific images and download them into a folder. There is also, we could critically talk about scraping too. There's big problems in there too, but that's another thing to discuss. But what I wanted to say is about the creation of data sets with scraping is also that you have to be quite clever in how you do the scraping. Like one of the first times I tried scraping, I actually wanted to create a Gothic architecture data set. Yeah. So I put into the scraping algorithm Goth, and he started to look for Goth images online for me. You can imagine how useful that data set was for architecture. It was a fun data set, but
I was going to say, like, maybe not very useful, but I'm sure that the process was extremely enjoyable to you in particular.
It was very funny. Yeah, it was very funny.
Beautiful. I'm going to relay a couple of questions that we have from the YouTube, but anyone from the call is welcome to intervene again. So we have a question from Gabby Perry, who's also an alumna from the class. And her question is whether if you can speak a bit more about how robots perceive space. She's particularly interested in the Robot Garden project. And also she's asking, why do you think AI design spaces might be better suited to these robotic methods of perception?
I think I understand the first part. I'm not entirely sure I understand the second part of the question.
I believe she may have understood that you claim that AI-generated spaces are better for robotic perception. That they might be.
Okay.
And you can expand on that. Why do you think so?
Yeah. So for the first part, like how robots actually perceive space, There's a variety of methods to do that. Like one is simple machine vision with cameras, and the cameras are connected to algorithms that recognize particular features. There are things like image segmentation and object detection that I mentioned in the lecture, which are basically designed. I mean, they come basically from things like, for example, automated cars, right? They have to have also these machine vision abilities to understand what is a pedestrian, what is the sidewalk, what is the street, and so on and so forth. And they're all based, again, on large-scale data sets that these machines are trained on. There's a very famous one called Imagenet that basically allows you, and this is the one that is used, and there's Imagenet and there's the COCO data set. Like these two are the ones that are very, very, very common and used a lot with automated cars, because also they have like millions and millions of annotated images, meaning there's like millions of images that are annotated and also segmented. So it's a segment that shows you that's a human. And because it's labeled and says that's a human, the machine over time learns how a human looks like. Yeah. So that's basically how they see space. The other way how robots perceive space is not just two-dimensional through the cameras, but using something called LiDAR. Light deranging. I forgot now what the acronym is, but basically it's a light beam that gets reflected back from objects, and that allows it to understand depth, like how far away is something. And this combination between images and LiDAR, images from cameras and the light reflection from LiDAR, allows a machine to understand its environment. Yeah, this is a super really simplified, but that's basically how robots perceive their environment. Yeah, and I consider a car with a bunch of AI technology to be sort of a robot. It's a large robot. Yeah, and to the second part, I don't think I'm saying that. Yes, exactly. Light detection ranging. Thank you very much. Yes, exactly. And to the second part, why an AI designed environment is better for robots, I don't think I have an answer for that. It was just an idea that we were bouncing back and forth with Michigan Robotics and told them, they were like, hey, you guys are working with AI to do designs, and you're actually using the methods our robots are using to see the environment. I think it would be a cool idea if you do the robot garden. Why not? Yeah, sounds good. I like that. Yeah. And by the way, I think it's the first architecture project ever built doing this, using these technologies.
That's awesome. That's very awesome. Architecture for robots. How many projects have been done for that?
Yeah, I made a joke to the director of robotics that I told him the garden was designed for robots by robots.
Nice. We have another question from YouTube from Avinav Nag. They're asking, can we use such programs in low-cost architecture?
That's a great question too. Yes, thank you very much. Absolutely. This is also one of the goals that I have with the lab. I made recently the argument that we can actually use AI to improve the living conditions of billions, basically, because one of the things that AI can do really great is optimization. So we are thinking really about how can we take like really tons of good examples of social housing, for example, and then train AI to come up with even better solutions for these plans. More logical, better in terms of material consumption, better in terms of ventilation, better in terms of, how to illuminate those spaces, like the things that you really need for an apartment to basically do something good with it. So I'm very excited about the possibility to use AI for the better of architecture. Not only, I admit I'm a formalist. I love form. I love shapes. But on the other end but there's also this, I think, obligation almost, I think, for architects to explore and exploit this technology to make better architecture for everyone.
Nice. Beautiful. Well, we're past 7 p.m. So unless there's any other questions, one thing I'm going to formally adjourn this lecture. Matias, thank you very much. It was a pleasure to have you here. It was very refreshing to hear your thoughts on what's going to happen or what's happening right now. I wish you all the best with the book, and hopefully see you in person sometime soon. I believe.
Well, I hope Arcadia. Hopefully.
Yeah. Arcadia.
All right. Perfect.
Well, and thank you everyone here on the call, on the YouTube live stream. Thank you very much. See you on the next, and a friendly reminder to everyone, this was the first on a series of 3 guest lectures at Introduction to Computational Design. The next 2 will be announced very soon. Thank you very much, everyone. Have a good evening.
Bye, everyone.